Thank you for making it to the final day of reInvent 2022. It's been a long week, but a good one, I hope. I hope we've all learned a lot. Happy to be presenting to you today. My name is Rob Aldrich. I am a Senior Solutions Lead in our Worldwide Specialist Organization, focusing on sustainability. And I'm very happy to be presenting here with one of Ryan and my customers, Jamel Frazier. And we're going to be talking to you a bit about a project that we've been working on together for the last year plus, and we want to share some of the lessons learned from that project. And if you have an interest in this space, we're hoping that you'll fit into one of these four general categories. I think this is who is going to get the most out of this session. If you are not in one of these specific roles, but support these roles as an IT professional or as a cloud architect, I think you'll still get some value from this session. And I think with these roles you see represented, what we're really talking about is the confluence of two very big technology areas: the operational technologies world that you usually see in buildings and oil and gas pipelines and utility grids, and the world of cloud that we all know and love. So that's what we'll be going through. And I think these lessons that we've learned in the last year are extensible in some of the design patterns that Jamel and team have specified for us to build in how we're acquiring data, and bringing that data up into new and interesting data visualizations that can drive people to take new action inside of buildings. And the way we're doing that is with some serverless management technologies and some IoT design patterns, as I mentioned, that we'll be showing you through the session. So to start out, we're going to talk about what are some of the drivers in real estate around sustainability. It's relatively new for a lot of building teams to do something beyond just reporting energy and actually being asked to do some transformation inside the business in some cases. Jamel's going to describe a bit about how we do building management at Amazon today. We think it's somewhat unique, and we think there are some benefits to the way we're doing it. And we'll capture those through the lessons we've learned in this project. And then we'll look to pull that together at the end to give you some actual advice on some next steps. This is a pretty new space for all of us, so it's a really exciting place to get together and do some discovery around. So to get started, let's look at what are some of the drivers that folks like Jamel are experiencing and being asked to do new things around to support. So I think we are all familiar that there is some regulatory compliance required for corporate level sustainable reporting. That's been the case for a number of years, but there have been some big advances in that space in the last 5 or so years, particularly out of the EU. The CSRD, the Corporate Social Responsibility Directive out of the EU, is having ripple effects throughout the globe and is really getting people to stand up and pay attention to some of those emerging regulations out of the EU. And then here in the US, the Security and Exchanges Commission is proposing that all 3 scopes of emissions, which I'll explain what those are in a second, be reported with sign-off attestation by the head of real estate. That's a big deal, I think, very different. And then corporations are also experiencing shareholder pressure. I'm a sustainability person myself, and I vote with my wallet. I try to spend my money on companies that I have confidence are part of the solution, not part of the problem, when and where possible. And I think you're seeing that reflected in a number of shareholder meetings and the feedback that all corporations are getting to try to be part of the solution moving forward. And then finally, in terms of recruitment and retention, employees are having an effect. In fact, I joined AWS about a little over under 2 years ago, and one of the things I saw from outside of AWS that really made me want to come here was I saw that 5,000 or so Amazon employees signed an open letter to leadership asking for more sustainable leadership. And that gave me a cue that this is the place to be, that there's a lot of people who want to do more in this space. And then, interesting, last point on employees, there was a survey done a couple of years ago by Epson that pointed out that 83% of employees said that sustainability was very important as part of their recruitment and retention for a company, but only 22% believed that the company had a plan to transform. So there's a little bit of a gap there that you should be aware of. So I think a lot of people new to sustainability make the mistake to think it's more complex than it is. So I wanted to demystify it a little bit for you and get you down to some key insights that will help you move forward with how to drive better data insights and analytics in this space. So the first thing is to consider prioritization. I mean, really as a species, what should we be focused on? Well, climate science tells us it's emissions. Emissions is driving climate change. A lot of these emissions also lead to respiratory illness. And you may be surprised to find that with our power mix here, with coal and oil still being king, that renewables is not moving fast enough to match up with what climate sciences is telling us we need to do to meet our targets. Building energy efficiency is also required. And building energy efficiency is only sustainable, only a sustainability project as long as those petrochemical sources are still top. If that were reversed and we were 100% renewable tomorrow, I wouldn't be talking to you about building energy efficiency as a sustainability project. I would only be talking to you about it as a cost optimization project. I don't mind if you're going to waste power if you're not creating pollution. It's your money. I would suggest you don't waste it, but that's where you'll hear us talking about energy efficiency. It's about using less dirty power. But most of us don't even know what our power sources are. What are we plugged into? Does anybody here know their home carbon footprint? I do, and it was hard to find out. And there's just not a lot of good data services and data tools there yet, and we're working on trying to build some of those, and we would hope that the rest of you might look to try to do that too, because knowing what your fuel source is for energy will help you be more intelligent about where you place your properties moving forward. One fun fact, what do coal and tuna fish have in common? Has anybody not been able to eat tuna when their spouse or themselves were pregnant? Have you heard about that? You're not supposed to eat tuna because of the mercury content in it for pregnant and infants. Well, how did the coal get in the ocean, or I'm sorry, how did the mercury get in the ocean to begin with and trickle down and magnify up the food chain? It came from burning coal. Burning coal releases mercury into the atmosphere, goes out into the clouds, falls into the ocean, goes down to the benthic layer, get eaten by little critters, back up to the tuna, into your sushi. So there is a fun fact you can think about on the plane home. And then when you look at how this energy is used, number one source of emissions impact is buildings. It's where we do most of our things. Somewhat close second is transport. So if you want to focus on using less dirty energy and make the fuel sources more aware to your business, give people better visibility to that, buildings is a great place to start. And everybody has them, even FedEx and UPS. Even though transport's probably their biggest, they still have buildings. So understanding some level of global energy economics helps. And then within how sustainability is managed within the business, we're focusing today mainly on the E within the ESG, the environmental side of that. And environmental comes down to emissions and then the toxicity of materials primarily. So if you focus on those two things, these 5 steps will get you started, and will get you started really at no cost to begin with, because most of in the early days is just benchmarking. Your business probably has not benchmarked their buildings yet to understand how efficient or inefficient they are, and they probably don't know what cost is being wasted and what emissions are being generated. So following this path of setting a benchmark, understanding what actions will deliver what results ahead of time is a good way to get started. And as you do, if you don't have a background in building management, the first thing you're going to recognize is the technology in that space is going to look very old to you. The data hierarchy and logic is all derived from a distributed control system reference model that came out in 1975. Hasn't really changed much since. And this is the logic that teams will follow in order to connect a device like an air conditioner through a gateway to an on-premises building server. And that's the way it's done for most of the building management systems in the world today. And as you scale this across the enterprise, what you'll quickly see is no two BMS vendors are the same. BMS vendors lock down their data in proprietary type of constructs, and that can make it very difficult to manage a portfolio of real estate versus just a single building. And so as you look at how to transform your business for sustainability, or you look to support a sustainability team as a real estate operator, you're going to see that the number one area that your sustainability teams are probably looking at is up at the level of the SDGs, the United Nations Sustainable Development Goals. There's 17 of them, fully 7 of them sit in buildings. And then moving past that, you're gonna need to figure out, okay, how do I get the data to show how good or bad we are on those 7? And you might find out that you don't have a lot of people yet that are looking at that data. So there's gonna be some level of business and operational scale that you're gonna have to assess. And then finally, when it gets down to the technology of how do you feed this, you can go to one BMS, and then another, and then another, and then another, and you end up with a lot of CSV files and a big data problem. So Amazon has clearly recognized that this older tech and this older way of managing buildings, it cannot keep pace with our growth and our variety of infrastructure and operations. So the old kind of design philosophy of one building to one manager is really being challenged with the project that Dramel is leading us on. And I won't talk through all of these benefits, but the ones you see on the right are pretty stock standard for our space. And many of those are not really apparent in a lot of building management systems today. So to sum it up and hand off to Dramel, this approach can drive you down the path of being data-driven with how you do your sustainable transformations. And we've got a number of tool sets that we've built and professional service offers and some different solution stacks that can support you driving sustainability through the cloud, which is a little bit different than on the cloud. You'll hear us talk about on and through. On just is for your workloads that you host in our data centers, and through is using our technology to manage all of your sustainability enterprise-wide. And that can be complex, but I would just have you take away one thing to remember, and that's technology's role in sustainability. Our best role is to provide, I like to call it the 3 M's for the 3 R's. If you don't know the 3 R's, it's reduce, reuse, recycle. It's kind of what, I'm not sure who came up with it, but someone came up with it years ago, and it's a good way to turn sustainability into a verb in your mind. Well, for tech, what we can do is give you the 3 M's. The first is measuring. Measure all your sources of emissions the same way. Standardize that edge. Once you do that, you can monitor your progress to improve them, and finally, you can get on a path to manage these, maybe manually to start, but then over time, you can automate those things. So measure, monitor, manage for reduce, reuse, recycle. And with that, I'd like to bring up Dramel. Thank you, Dramel. Here's your clicker.
Thank you, Rob. I'm Dramel Frazier, Senior Program Manager on Amazon's Rural Real Estate Engineering team. And today, I would like to take you through a journey on how we at Amazon is basically driving energy optimization through the use of AWS managed services. This journey first begins with a problem. The problem that we're looking to solve is how at Amazon do we drive energy optimization as a goal, as a whole, as an organization, throughout our platform from a global perspective. Another goal we were looking to solve is how do we plug in to our facilities and immediately start receiving data the minute in the day that they come online. The other initiative we were looking to solve is how do we monitor and increase our availability and uptime of our facilities and the equipment that operate inside these facilities. And also another objective we're looking to resolve is how do we reduce year over year our energy consumption. With that forward vision in sight, we then looked at our existing infrastructure and data to then make the decisions on how we move forward. The first thing we had observed is all the disparate building systems and protocols throughout our facilities as one of the problems we documented. The other issue or problem that we documented was all of the non-integrated data sets throughout the various different facilities throughout the world. Another realization that we came to is how do we integrate and access all this information and data from siloed data sets or from siloed databases? And in addition, how do we basically create a way to eliminate multiple analytical tools across the entire platform? And with that, we formulated key questions that we want to try to answer holistically as an organization. One, how do we create a more sustainable future? Not only do we create a more sustainable future, but how do we power that with AWS? In addition, how do we create a single data standard across all of the various systems and data sets and databases while also achieving a more sustainable future. And another key thing that we also want to solve is how do we create data-driven insights from all the information and data that we're receiving from all of our information. Our first realization into landing all this information into a single data set really supported the need that I just highlighted on. Presented here is two key services that has leveraged Amazon that has provided insight into how we look at our facilities today. One of them is through the use of Grafana. With Grafana, bringing in all the data into a single platform throughout the entire portfolio, we're able to visualize all of our alarm data into one single place and get a holistic understanding and basically hand it to analytical teams to then drive better uptime and availability in our facilities. We've also been able to leverage Amazon Lookout for Equipment by providing Amazon, also known as L4E. With providing L4E, our historical data and information, we've also been able to provide and look at the building performance through both of these Amazon use case tools that we've used today. And with that, I'm going to hand to Ryan Burke to dive a little more deeper.
Thanks, Jamil. Hi, my name is Ryan Burke. I'm a senior application architect at AWS in our worldwide specialist organization focusing on sustainability. I joined the sustainability domain at AWS about a year and a quarter ago. I come from about 10 years experience in the IoT domain, so if you see me at past reInvents, it's probably giving some IoT presentations just like this one. So we wanted to bring some of the key lessons that we learned from working with Jamil and the real estate engineering team at Amazon out to our audience here at reInvent. And so some of the key lessons that we wanted to focus on, one is to capitalize on what Rob was saying about measuring, monitoring, and managing. In order to measure, we have to use a series of IoT inputs and sensors and any kind of data we can get our hands on from any kind of data source to ingest the data that tells us what's going on in our buildings. Second, we have to consider how do we store that information in the AWS cloud in an efficient way and make it available for downstream analytics, machine learning use cases, informing our operators what is going on in their building. The story's not over just by ingesting that data and storing it. And so the third thing we wanted to focus on is the role of machine learning, artificial intelligence, and other advanced cloud capabilities in the role of transforming raw data into intelligence and then intelligence into insight. And then finally, we'll take a peek at one of the experimental user interfaces that we've been working on to capitalize on these great learnings. And I hope that you'll find that exciting to see. So where do we see IoT delivering the most value across these four areas? Of course, it's in the ingestion part, right? So we have a number of services within the IoT category of AWS to help us collect information at the edge, transmit it up to the cloud, store and make sense of that information, but also now we have services for rendering insights back to customers, back to operators. And so IoT really takes an end-to-end role in our modern building management systems. So starting with ingesting the building data, what were some of the top challenges that we faced working on this project over the past year? So I wanted to talk quickly about data acquisition versus data ingestion. So if we think about acquisition as the conversion of analog signals into digital signals, something that we can actually work with over a network and bring into the cloud. Ingestion is the bridge from the edge to the cloud, so difference between acquisition and ingestion. With this project being built on top of local BMS systems to handle communications with individual equipment and sensors solving the acquisition part of the problem, we were able to focus on the ingestion story. So how do we best scale the number of buildings and properties that Jamil's team manages at scale and bring this quantity of information, which we'll take get a sense of in a coming slide. How do we work with that in the AWS cloud? And so we acknowledged early on in the project that not all telemetry that we're collecting from the edge is going to communicate with a gateway and be routed up to the cloud via a single BMS gateway. As new technology comes out, we want to keep our options flexible. So as more maybe cloud-native sensors and equipment becomes available, commercially available and usable to solve some of our monitor and measuring challenges, we want to be able to integrate that into the modern BMS that we were designing. So thankfully, we didn't need to innovate too much to secure the building data in our ingestion layer. We're able to follow a bunch of best practices from the AWS IoT services and our solutions architecture learnings from the past, 7 years of operating the IoT core service. So on the slide here, we have a couple of those best practices that we were leaning into. So we're using public key infrastructure with X509 certificates to bridge the communications, that data ingestion layer, so that we're able to take advantage of mutual TLS from all of the connections from the edge to the cloud. So in mutual TLS, the client is able to validate the service is who it claims to be, and the service is able to validate the client is who it claims to be. We're also able to take advantage of certificate rotation by basing our solution off of this. This is also a best practice for operating any production IoT workload, is making sure that you're rotating those certificates over time. And finally, we wanted to make sure that only those operators of the AWS solution have role-based access to be able to see any of this building telemetry as it moves from the edge to the cloud, but also once it's stored in the cloud. And so we're using role-based access as a best practice to scope down who has access to what kind of data and when, and make sure that everything is maintaining as high a security posture as we can. So I talked about just the sheer volume of data that we're working with in this space, and so I wanted to give some contextual example here. But we estimate a single commercial building, size varies on the definition of commercial building, but estimating a commercial building to generate anywhere around 30 gigabytes of information just from the telematics of the equipment, heating and cooling and ventilation, lighting, electrical, plumbing, all of these systems can generate up to 30 gigabytes of information per day per commercial building. If you multiply that out over 365 days a year, because these buildings are running 365 days a year, that one building is going to generate, on the order of 11 terabytes of information. And for any portfolio of a real estate management group, if you're operating even 90 buildings, you're looking at a petabyte scale solution every year. So we have to make some considerations about how we make best use of the IoT layer, the acquisition and ingestion, but also the downstream data storage platform of how we are going to store and access all of that information. And so one of the things that was important in this project was transforming the model in which we are operating any one building, because now we're trying to look at insights and generate intelligence into insights, not just within any one building at any given time, but we want to learn more about what's happening across the portfolio of buildings. And so the IoT layer helps us bridge this gap and moving from a model of one building, one server to store everything, and one team looking at that one building, to a model on the right side of the slide here, where we're starting to scale cells of IoT core accounts to manage multiple buildings. And that helps us scale out that acquisition and ingestion layer. And then we're forwarding all of the acquired telemetry into a central data lake account to empower our ML and AI and analytics use cases. And so what this helps us accomplish is that we're able to scale, or instead of scaling with server counts and licenses and dedicated staff, we're able to use managed and serverless AWS services to help us better scale just for the number of basically a data-based scaling methodology. The number of buildings is not as important as just the sheer volume of data that we're trying to capture. And so here's a peek into one of the architectures that we're using as a reference for this modern building management solution. In this case, we're looking at more of an exploded view of the multiple communications channels and data paths that our publish and subscribe accounts are using to process data in a global data lake account. And so what we can see as we move from the left side of the architecture diagram to the right side, we can see, kind of top to bottom, just the number of different types of systems and services that we're able to accommodate in that bridge from the acquisition. So each one of those endpoints on the left-hand side represents some sensor, some mechanical device performing the acquisition. And then we have local BMS represented in blue, kind of in the top right of the left-hand rectangle. And then we also use, or in our reference architecture, we can use things like IoT greengrass and further gateways to help us accommodate the acquisition and ingestion to the cloud for even more edge services and mechanical hardware. And then kind of along the bottom path there, you can see we also have routes for maybe more IP-based equipment that we can bring on site that can just send information to an API. We're able to facilitate inclusion of an acquisition and ingestion pipeline that can go straight to the cloud using HTTPS APIs. So this gives us flexible connection options for building out infrastructure and operations. These methods are highly repeatable to add new assets to the cloud. Like I said, we want to be able to keep our options open, right? Our primary goal was to onboard any of the local on-site BMS technologies that are out there today. We want to be able to add new assets to the cloud as easily as possible. And this is also the first step in making sustainability initiatives data-driven by getting this information into the cloud. So another thing I wanted to focus on was the diversity of data types, or diversity of device types in IoT, and in particular in the building management space. So this is one of our key lessons that we learned, is that we thought about, okay, what if there was just one single ingestion point and ingestion model, right? One endpoint, one data format that we say all information has to be communicated in this schema so that we can enter it into our data platform. Okay, makes sense. Helps us get to a more normalized and standardized data model. But as we looked out at the range of diverse devices and equipment and protocols in the industrial IoT, and in particular the building management space, we would have been writing a new abstraction layer for every single protocol, every single device, and we weren't going to be able to scale that quickly. So we were able to lean into the value that the incumbent BMS technology brings us, which is in performing that localization, or sorry, the normalization of that vast diversity of device types, and we can focus our abstraction layers to fit against any of those local BMS systems, right? They do a lot of work, they have a lot of experience performing that acquisition and working with these various protocols. So by affixing a layer, an abstraction layer on the, I guess, right-hand side, if I'm moving left to right, to help us bridge that vast diversity of device types, but also protocols into the cloud. And so we prescribe, for a heterogeneous IoT solution, to bring a layering approach to normalize that abstraction and bring that diversity up through multiple layers. And that's kind of what the triangle represents, is if at the top of my triangle I have my data platform that almost necessitates a single data schema, every layer below that represents a wider amount of devices and protocols, but through our abstraction layers, where IoT Core brings us a lot of value, and things like IoT Greengrass bring us a lot of value, we're able to move data through into that singular data schema that we can use downstream. So don't try and design a single cloud interface to accommodate all devices, all clients. You want to really embrace the diversity. It's important to preserve for your speed and agility. Okay, so moving on to data platform considerations. In the analog world, not all data is equal in terms of where to effectively process it. If it can be processed in isolation, or it only makes sense when combined with other data, is one consideration. How quickly the data must be consumed before it loses value is another example. So if I'm in a building and I'm setting a new value in a room's thermostat, that's not as time critical, right? We can respond to that within a few seconds, maybe even a minute, compared to some information I'm getting from my 10-ton rooftop unit that I've paid a hefty sum of money to help keep my building cool. Signals that might indicate that equipment is about to fail. I need to process that information as soon as possible. So just an example of some different data velocities in this space. We also see these questions arise in many IoT projects, but almost always in industrial IoT, where we have that diversity in the physical and operational systems like HVAC and physical security, power and electrical, and so on. And so the speed with which the system needs to process operating conditions to prevent failure is much more critical than processing an update from maybe a human element. So these considerations inform how we design the data ingestion and data storage layers. A solution with purpose to inform a sustainability strategy must itself be sustainable. If it's too costly to process every datum at the same speed, then we need to break up multiple channels for these different data velocities. And so a well-architected approach to serverless building management will use a mix of hot, warm, and cold data pipelines and require a data classification exercise, right? You'll need to profile the systems of your building. Thankfully, at least in the building space, we can all learn as a community very quickly where the best practices are here. But a data profile or a data classification exercise will vastly help you best price out those hot, warm, and cold data channels. Sorry, that wasn't me. So as we look at two architecture diagrams here, we'll kind of take a look at a batch processing example here and compare that to a kind of more of a live, real-time architecture on the next slide. But what we can see here is that the shape of the architecture is actually relatively the same, and I'll kind of bounce back and forth a couple times to illustrate that point. But we're getting information in from the edge. IoT Core is our primary hub in which we are ingesting the vast majority of information. But we're using channels like Kinesis and S3 and Glue to be able to process this information in large volumes in batches at a time. And by focusing part of our data pipeline and our strategy on this kind of batch processing model, we're able to cost optimize a large quantity of that 30 gigabytes of building data per day. What we found is that we want to prioritize that critical infrastructure telemetry over our most expensive and hot data channels. But anything that can wait, we can tolerate being batched into something that we send up every minute, every 5 minutes, every hour, we can dramatically cost optimize the total cost of ownership of the solution. And so I'll advance here, and you can see now, when we look at the near real-time processing architecture, again, the shape of it looks very similar. We have an edge to cloud story on the left-hand side. IoT Core is our primary hub, but we're using more of our streaming Kinesis services to process individual messages, but also more time-sensitive information that's all relevant to each other, and be able to make decisions and generate insights on that much more quickly. So one thing I wanted to focus on was what does it mean to truly digitize a physical space? And so to do that, we're really uniting three different kinds of information, three kinds of data. So we're trying to unite the relational data, the time series telemetry, and spatial data. So in the building context, what does relational data mean? It means, what are the mechanical assets, what are the sensors, what are the logical entities, like a room or a floor or a zone, that make up my building. The time series telemetry is, of course, the runtime telemetry, the sensors, the feeds that help keep my equipment running and healthy, and what's going on in my building at any given time. And then the spatial data is also the more three-dimensional geospatial context of, I may have these 10 RTUs on the roof, but where exactly on the roof is each of my rooftop units positioned? Because what we're learning is that depending on where on the building or where on the roof a particular device is installed, we may see performance differences just based on the sun going over every day, and then over throughout the year, how the angle of the sun may be impacting the runtime temperature of this equipment, right? So where the equipment is within the building, how it's related to other equipment and logical entities within the building, and what's going on with my equipment at any given time. To truly digitize a building, we need to unite all three of these kinds of data. And so this takes us into the role of machine learning, artificial intelligence, and advanced analytics and cloud capabilities. So Andy Jassy, one of the quotes that always stuck with me, our CEO at Amazon, is that there's no compression algorithm for experience. So what does he mean by that? He's saying the experience of getting into a new space, and my ability as a person to learn a new domain and become an expert, right, by gaining experience, we can't accelerate that with technology so much, right? I still have to learn and understand and become an expert in that space before I can competently influence that space. However, with the advent of machine learning and this ever more democratic approach and lowering the difficulty bar of moving into ML, we can take accumulated experience and we can compress that into an algorithm. And so that's what we're doing in this project. And so I've got on the slide here a couple different examples of how we think about AI, ML, and advanced analytics in influencing the measure, monitor, and manage cycle of a building management solution. And so, three categories here. One is AI in support of simple sustainability KPIs or key performance indicators. We have services like Amazon TextRack that can help us translate, a paper or PDF utility bill document into the total quantity of energy that my building consumed, and make that easily accessible in machine data, so that I can join that with all of my IoT sensors and the equipment telemetry that I'm getting from a BMS. An example from advanced analytics to alleviate manual effort, right? Manual effort is boring. Nobody wants to do manual effort, the same task day in, day out. And it's also really challenging for a human to look at hundreds or thousands of KPIs and pick out interesting information from across that vast quantity of KPIs and detect those complex events. So we can train machines to look at that vast information and yield insights to us. We can also yield deeper insights and empower our junior operators who are still learning their craft, right? So while there's no compression algorithm for experience, we can compress the experience into algorithms and make it more accessible to our junior operators to help them become more competent in their craft by leaning on the expertise that we've got from the industry. And finally, ML to study and inform complex challenges. So one of the projects that we were using all of this IoT data to compute and get value from is by looking at how the rooftop units can be optimized with their operating parameters to maximize, to increase their remaining useful life, abbreviated here as RUL. So how can we use machines to help us understand and predict how might we be setting the runtime parameters of our equipment to even 1 more month, 6 more months, 1 more year of operational life out of those, or to lower the total amount of energy, but also meeting the same goals of ensuring equitable and hospitable conditions for the people who are within those buildings. And then one of the questions that we ask is why are we doing all of this work? It's not just to help Amazon meet its sustainability transformation goals, but we've also found some ways in which once we have the data in the AWS cloud and we can put it in the hands of builders and innovators, what can they come up with? And so we have one experimental user interface that we've been working on. You may have seen it An example of this in our AWS industrial booth just across the way here is by uniting those three different kinds of data into one interface, the relational, the time series data, and geospatial information in one service like AWS IoT TwinMaker, we're able to build interfaces that give our operators way more context about what's going on in their building by uniting all of this information in one place. And so what's playing on the screen here, just a short loop, is an experimental user interface where we have a shell of an Amazon fulfillment center building. We're plotting out all of the HVAC equipment that's throughout that building. We're able to tie in the relational data of how these HVAC equipment relate to each other, how they relate to rooms and floors, those logical entities within the building. And using the new knowledge graph feature of IoT TwinMaker, we're able to give our operators more context about, say if one alarm goes off for one of these rooftop units, what else can we tell the operator about that event through that knowledge graph to say, well, this is impacting these rooms, these floors. It may have a cause that's not originating at this equipment, but it may be related to something else that's going on in the building. Then now we're measuring as a downstream impact. By being able to provide that kind of context, by uniting all this information, we're able to give our operators much more context. But we wouldn't have thought to try this out with, until we had this data available and started to experiment with it. So this is one of my key lessons for you, the audience, is that the fusion of disparate data sources can synthesize new insights, but we have to try things out. And it's a lot easier, it's a lot more cost effective to try things out using the scale and speed and cost effectiveness of the cloud. So once the data is in place, secure and accessible, go build stuff, go try it out, right? Because it's only through experimentation that we're going to find really interesting ideas like this one and start to test them and see what we can do to help accelerate that sustainable transformation. So with that, I will hand it back to Tramel.
Thank you, Ryan. So I'm gonna go back to that journey again to where, how do we start? How do we start to even evaluate and knowing something like this is even feasible within our facilities as an organization? It all starts by understanding your current state and systems of where you are today. What different building system protocols do you have? What types of vendor manufacturers do you have? And for us, as an organization, we had to evaluate this globally. Look at all of our systems holistically and understand what level of effort are we basically proceeding here? What is the feasibility of doing something like this? This is essentially what we evaluated in order to undertake an effort like this. Once we had understanding of that, the next thing that we basically embarked on is really one of the most favorite things I like to do within Amazon. And it starts with our customer accession. Essentially, our next step was basically starting with the customer and working backwards, understanding each part of the organization of everyone that was going to interact with this platform to understand their use cases so then we can then go out and build them. This is where we started to develop our user stories to then build our backlog so that then we could create the development cycles to then build this analytical platform that will expand globally. Once we were able to achieve some development cycles, then we landed on a minimum viable product, or MVP. Once we had a MVP, we then put it out to additional stakeholders to allow them to get a look and feel of what we built up to that point in time so that then they could provide additional feedback into additional things that we can provide them and additional insights so that we can continue the development cycles. And lastly, the ultimate product that we wanted to create is take all that information that we've learned from our customers, all of the insights, all the development cycles, and create what we call a single pane of glass from an entire data set or portfolio from around the world to where we can both manage building performance, and maintain building insights. And with that, I'll hand it back to Rob.
Thank you, Jamal. So we've covered a lot of ground. We just want to sum a few things up for you, and I think for most of us, we're probably flying out right after this, so we'll try to keep it quick. I know it's been a long week. So I think a few key takeaways we'll talk about in terms of content for next steps in a second here, but just in terms of what you can take back to your day job, keep those 3 M's in mind. That'll help you define what it is you can do with tech to support sustainability transformations or sustainability data automation. And as Jamel suggested, working backwards is a great way to do that. That's how we generally do it here at AWS. Have an end state in mind, however long out you think it'll take, 1 to 3 years usually for a larger project of any kind. And then, make sure you hit key milestones along the way. Some of these tools will help you do that. Our ASDI, or Amazon Sustainability Data Initiative, I would invite you to check out when you get back. It can host large volumes of sustainability data, sometimes at no cost, and it can give you access to a lot of sustainability data that other partners of ours have hosted there. Second, a partner of ours, Schneider Electric, has a great white paper, number 67, that has a number of sustainability KPIs. It's got a good list of KPIs you can take into your business if you want to drive those 3 M's across your operations. It's going to look like a data center white paper. That's okay. Anything you can do in data centers, you can do in other buildings too. You may not want to do all of it, but from a KPI perspective, it's great. The Green Grid, of which I'm a former member of, I'm also a former user like Dramel, a former Chief Sustainability Officer at Cisco, and we spent years at the Green Grid giving you some good guidance on how to drive things to be more efficient. And with that, I think we'll all beg you to fill out your session surveys, please. It really helps us to get the feedback we need. And then a few of these white papers that are featured here will help you reinforce some of the concepts we covered off. And as you're doing that, you can also search our names. We all have a number of blog posts out there, or will in time. And the blog posts that you'll see in the last year, at least from myself, are representing some of the we have done here. So with that, I'd like to close out. We don't have time for questions, but at least I'll be standing up here. So if you would like to come up and chat, feel free. And guys, you want to come up and just take a bow, and we'll say thank you and appreciate your time.